Hello, this is a video of day 17, unit 4, or unit 3, but it's chapter 4. This is in line with everything we've been doing with the remainder theorem and basically just finding the zeros, kind of the point of the unit. And we can just straight up use Desmos to do that. So that's kind of what this lesson's about. We're going to locate the zeros of a polynomial function using Desmos. And, just if we have long decimals, just round them to the nearest thousandth. So here's an example. You just plug them straight up into Desmos. You have it's degree 2, as you can tell, because its highest exponent to a variable is 2. So you have 2 real roots because both of the roots are x-intercepts, and there's only 2 total. So we'll try our own. This will be, you could type f of x if you'd like, or y equals if you'd like, but Desmos makes it not necessary. That's third minus 3x squared minus 3x squared minus 3x. All right, so we see this the graph of this function, and it crosses the x-axis. It looks like 3 times. You can click on which points they are. And so the zeros are the x values of where the graph crosses the x-intercept. So I can write that down. And better yet, so we're interested in, x equals, we'll have 3 of these, but for sake of expediting this process, I'll just take a snip. And this is what it looks like. So I just took a quick screenshot, so I don't have to like tab over and copy them all the time. But this would be negative 1.361, 0.833, and Desmos is automatically giving us it to the thousandths place, so that kind of works out. And so there we have approximated the zeros. We don't know how long these decimals go. The Desmos is just going to get to the first thousandth. That's why it's an approximation. It's not exact. We'd have to factor it and solve it to determine that to be absolutely certain, for it to be exact. And then we can try another one here. 2x to the third minus 4x squared. So 2x to the third. We'll just try and modify this one. 2x to the third minus 4x squared minus 3. Okay, looks like that did it. And just to show this, I guess, you can have the f of x in front of there, and it doesn't change anything. Or you could have y in front of there, and it doesn't change anything. It's the same as just the function. Now, I have some points of inflection here, some interesting points. That's like kind of like a peak. We can talk about that later. That's kind of like a valley. Talk about that later. But again, the only thing we're interested in right now is this point, because it's the 0, and we're looking for the approximate zeros. So 2.287. So this would be 2.287. And I could, I could screenshot this again if I wanted. Sometimes that may be helpful. And I just kind of included some of the points of inflection, but really the only thing I care about, again, is the 0. All right, and you can do another one down here. So this is pretty much all of day 17. This is all it's about. X squared plus 3x plus 2. That's x squared plus 3x plus 2. And again, there's a couple other points that Desmos can show me when I check out this graph. They have like the vertex down here. They have a y-intercept, but again, I don't really care about that right now. Just talking about the zeros. -2 and -1. And we could kind of know that already if we looked at this and we saw that this was factorable. You know, what two numbers multiply to be positive 2 and add to be positive 3? 2 and 1. Set them equal to 0 and solve, you would get x is negative 2 and x is negative 1. So again, approximating zeros isn't too challenging. Just type in a Desmos and see where it crosses the x-axis. Those are the zeros. Any other point that Desmos gives you that's not on the x-axis isn't related to the zeros as we are as what our scope is right now. All right, thank you. Good luck.